Hey, hello there, welcome to CS School channel. In this video we are going to solve n rows of Pascal's triangle problem. This problem is asked lot of time in different coding interviews. I have added link to this problem in the description of this video, so do check it out and try to solve it on your own. If you can, come back to this video. Now let me explain the problem statement which is shown on the screen. You are given an integer n and you need to find the first n rows of Pascal's triangle. Now what is a Pascal triangle? As you can see on the screen, each Pascal's triangle starts with 1. The number of elements in each row are 1 greater than the number of elements in its previous row. So in the first row there is only 1 element, in the second row there are 2 elements, in the third row there are 3 elements, so on and so forth, right? Each row always starts and ends with 1, and the remaining integers are calculated based on the 2 adjacent integers from its previous row. Like this 2 is calculated from adding 1 and 1 from this previous row. This 3 is calculated by adding 1 and 2 from the previous row, so on and so forth, right? So this pattern repeats in this triangle. Now let's look at some of the sample inputs and outputs from this problem. Okay, in the first example we are given the input as 5, so we need to return the first 5 rows of Pascal's triangle. The output is a 2D array where the first element in the array is the first row of Pascal triangle, the second element in the array is the second row of Pascal triangle, and you get the idea, right? In the second example we are given the input as 2 and we need to return the first 2 rows of Pascal's triangle, and here we have shown the output for the same. Okay, now how should we solve this problem? To solve any problem you need to look at what are the different patterns that the problem shows to us. In this problem, the first pattern is how many elements will be there in the nth row. So if you look at, in the first row there is only 1 element, in the second row there are 2 elements, in the third row there are 3 elements, so on and so forth. In the nth row there will be certainly n number of elements. Okay, the second pattern is each row starts and ends with 1, which is also shown in this diagram, right? Each row kind of starts and always ends with 1. The third pattern this problem shows is that the remaining elements are the sum of I minus 1th and ith element from the row above. Consider this example of this 2. So it is the second element in this row and it is sum of the first element and the second element from the previous row. So I minus 1th and ith element from the previous row. Okay, so hope you got all the patterns in this problem. Now we will create an algorithm based on the patterns which we have seen previously. So what we will do in this algorithm, we will first iterate from 1 to n. The n is an input given to us. In each iteration what we will do, we will create a row array which will store all the elements in a particular row for us. In the row array we will insert 1 at the start and end, and we will calculate all the remaining elements by just summing up I minus 1th and ith element from the previous row. So hope you got some idea about the probable solution. Now we will implement this solution using C++. Now let's look at the C++ solution for the Pascal's triangle problem. As you can see on the screen, we need to complete this function generate Pascal's triangle, which take num rows as an input and it expects 2D vector as an output from this function. Okay, so the first step is to create 2D array which we will return as an output from this function. So if you remember, the first element in Pascal's triangle is an 1, right? So that's what we will be doing now. So what we have done, we have just pushed 1 as the first row in the Pascal's triangle. Okay, now we need to iterate over the remaining rows. So we will start the for loop with 1 and we will go till num rows minus 1 times. Okay, and each of this iteration what we will do, we will create this row array. In this row array, if you remember, let me just show you the diagram. So if you remember, all the rows starts and ends with 1, right? So that's what we will do next. So what we have done, we have pushed 1 at the start and 1 at the end of this row, and we have written this for loop which will fill out the remaining elements in between elements, right? And what we are doing here, we are iterating from 1 to second last element, right? And we are inserting the value of that particular element, which is the addition of j minus 1th and jth element from the previous row of the Pascal's triangle. Okay, so hope you got an idea about this set of code, right? And at the end we are just pushing that row in the resultant array and we are returning that resultant array at the end of this code, right? Now let me just run this code. For that I have written this main function in which I am calling this get Pascal's triangle function with a value as 5. So I will get first 5 rows of Pascal's triangle in this response, okay? And after that I have run the for loop to print out this response. So let's see the output now. So I have opened my terminal. Now let me just run this code. Okay, so I get first 5 rows of Pascal's triangle. Now I am changing the input value from 5 to 3 to get the first 3 rows of Pascal's triangle. Let me just compile and rerun this code again. So what's the time and space complexity for this solution? As you can see in the solution, there are 2 for loops which kind of go till n. So naturally the time complexity comes to be O of n square. And same goes for space complexity. We are creating a 2D array here which we are returning at the end of the solution. So the space complexity again goes till O of n square. So hope you got an idea about the problem and its possible solution. If you like this video, press the like button and do follow the channel. Stay tuned for the further videos in this series.